Okay, welcome. Today we're going to look at graphing the sine and cosine function, so let's go ahead and get our notes out and we'll get going. Remember during the video, if you're falling behind, to pause the video and get caught back up, or if you didn't quite understand something the first time, to stop the video, rewind it, and listen to that piece again. Sometimes it takes a couple times through to understand the concept. Okay, let's go ahead and look at the sine and cosine graph. So here we have the parent graphs, and you can see they're very similar. Now, if I want to sketch either of these graphs, they're both done the same way. We sketch the basic sine and cosine graphs by simply finding 5 key points. These points are the intercepts, the maximum points, and the minimum points. So as we look at both graphs, we can see that these points are evenly spaced. So the concept we're going to use to sketch the graph is find the left endpoint and the right endpoint of the period. So on the parent graph, it's at 0 and 2 pi. But with the shifts and translations, it will change. So we're going to find these 2 points, and then we're going to use the midpoint formula to find the middle point, and then we'll find the quarter points, using, again, the midpoint formula. From there, we'll just sketch the graph. Both graphs are done the same way. All right, let's start with our first example. We're going to do a sine function. And remember, again, cosine's done the exact same way. So our sine function is -5 times the sine of pi x minus 4 pi minus 3. So the first thing we want to look at is finding the endpoints. So our left endpoint is simply, there we go. Our left endpoint is simply looking at the argument, pi x minus 4 pi, and we're going to set that argument equal to 0, the original left point of the parent graph of sine and cosine. So we're going to set it equal to 0, and we're simply going to solve. So to solve for x, I'm going to add 4 pi. So that would leave me pi x is equal to 4 pi. And then we're going to divide by pi. So solving for x, our new left endpoint is going to be at x is equal to 4. Okay, our right endpoint, we're going to use the same concept. We're going to take the argument, and we're going to set it equal to the original right endpoint of the parent graph, which is 2 pi. And then we're going to solve again. So with a quick solve, we can see that x will equal 6. So there's our new left and right endpoints. Now as I graph, I'm going to sketch a graph by hand. I am going to realize my graph isn't going to be quite to scale. Okay, we're after the concept, not actually trying to get the right scale on this today. So there's 4 and there's 6. Alright, so this is going to be one period of our sine graph. It's been shifted over and shrunk or stretched a little bit. So our next point is to find the midpoint. So now I'm going to use my midpoint formula. Now I can see the midpoint between 4 and 6. That's simply 5. But we're going to get a lot of numbers that we're not going to be able to see. So to find the midpoint, I'm going to go down here in the corner. I'm simply going to add 2 endpoints together using the midpoint formula and divide them in half. That should be a 6. 4 plus 6 is 10. Divide them in half, and I get 5. So let me separate this a little bit, and there's the midpoint of our graph. I get to the 2 quarter points. I can obviously see what they are as well. I'm going to use the same midpoint formula. I'm going to go 4 plus 5. So each endpoint added together, divided in half, and that's 9 over 2, which is simply 4.5. Now, I can do the same thing on this side as well, but I can see that's also going to be 5.5. So again, to find the midpoints, we're using the midpoint formula. The endpoints added together, divided in half. Okay, now I know where my max and mins or 0 is going to be on the graph. The next couple things I have to look at is the vertical shift. Now this one's been shifted vertically. I apologize again for not having a whole lot of room to write. This has a vertical shift of -3. So -3 means my whole graph translates down 3. So all my 0 points, all my max points, are all going to move down 3. So again, not to scale, I'm going to go ahead and start moving everybody down. Now these 0 points were on the x-axis are now going to go down 3. And they're going to be right here. So what I'm going to do is I'm going to draw what I'm going to call a midline. And that's just kind of a marker to see where my zeros are going to cross. Alright, so I've got my midpoints, I've got my vertical shift, and last I need to look at my amplitude. Okay, and again, I apologize for the writing. These tablets are very difficult to write on. So my A in this case, if I look back up top, is -5. Now I've got two things going on here. I've got the fact that my amplitude is the absolute value of A, which is simply just 5. I also notice that my A, -5, is less than 0, which means this is a reflection. My graph has been reflected. Again, apologize for the writing. Alright, so the original sine graph looks like this. Is now going to be reflected. Instead of going up, it's going to come down first and then go up. It's been flipped over. So I have to keep that in count as I start to sketch it. Okay, so we have our amplitude of 5. So from my midline, I know the maximums will be 5 up from the midline. So I'm going to count up 5. 1, 2, 3, 4, 5. And I'm going to draw another dotted line. A dotted line again is just guide me in my graph. And I'm going to go 5 down. 1, 2, 3, 4, 5. And again, another dotted line. So this is the upper bound and the lower bound. Okay, I know sine starts at 0. And again, it's been reflected, so I need to think about my starting point will be here at 4. And 1, 2, -3. And instead of heading up to a maximum, again, because of the reflection, I'm going to head down. So the next point is going to be my minimum point. And then once it hits the lower boundary, the minimum point, it's going to jump back up. And it's going to cross through at 5. There's your next intercept. And then it's going to go all the way up to a maximum point at 5.5. And that occurs at 5.5 and 2. And then back to our 0 line. Now the tendency is to try to put it here because it's your x-axis. Remember, it's been shifted, so your 0 comes here. And to sketch one period of sine, we go connect the dots. And there is one period of our sine graph. Okay, I apologize again for the writing. Again, it's on a tablet and very difficult. But remember, the concept is the same for both sine and cosine. Find the left endpoint by setting the argument equal to 0. The right endpoint by setting the argument equal to 2 pi. Get your endpoints. Okay, we're going to divide it up into fourths. Okay, so we'll have to use the midpoint formula to have to do 2 endpoints to get the middle point. And then 1 endpoint with a middle point to find each quarter point. Once we have those points, we've identified where all our max, mins, and zeros are. So it's just about looking at the amplitude and our shift. Shift the 0 line down, use the amplitude to find the max line and the min line, making sure that it's not reflected or is reflected, and plot our points and connect our dots. Okay, I hope this video helps. I do want to add one more thing. Remember that cosine actually starts at our maximum. So before we end the video, remember cosine actually starts at our maximum. So I'm going to jump back. Cosine actually starts up here. So if we do a cosine graph, we have to start up at our maximum and head down. Unlike sine, we started at 0 and head up. Okay, again, I hope this helps in graphing sine and cosine. If you have any more questions, jot them down and we'll answer them in class. Thanks.